Okay, I'm looking at question 2 of my little MYP4 diagnostic test. Find the rule. Find the rule for the nth term of the sequence 11, 14, 17, 20, 23. So if I think about n, which is the position that a number is in the sequence, and the nth term, I can make a little table. So the first term is 11, the second term is 14, the third term is 17, the fourth term is 20, the fifth term is 23. So the n is just the number where your position in the sequence, and the nth term is the number that's in that position. So I notice that every time n goes up by 1, the nth term is going up by 3. So that's what's giving you a little clue that the nth term, or the rule for the nth term, could involve 3 times n. So if the rule was 3 times n, then the terms you get would be 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 3 is 15. So you do get a sequence that goes up by 3 every time, but it's not the right sequence because we're getting 3, 6, 9, 12, 15. We want to get 11, 14, 17, 20, 23. So the numbers I'm getting, I need to add something to all of them to get the numbers I want. 3, I need to add 8 to get 11. 6, I need to add 8 to get 14. So I need to add 8 every time. So in other words, the rule is 3n plus 8. You take where you are in the sequence, you multiply it by 3, and you add 8. So 3 times 3 plus 8 is indeed 11. 3 times 2 plus 8 is 14. 3 times 3 plus 8 is 17. 3 times 4 plus 8 is 20, and so on. So the rule in this case is that the nth term is 3n plus 8, where the n is the position you're at in the sequence. So if you wanted to know the 100th term of this, you just go 3 times 100 plus 8, 308. So the 100th term of this would be 308. Okay, question B on find the rule. Same sort of thing. So you've got n, which is where you are in the sequence. 1 for the first term, 2 for the second term, 3 for the third term, 4 for the fourth term, 5 for the fifth term, and so on. And then you've got the terms themselves, the nth terms. So the first term, let me just write nth term 16. So the first term is 16. The next one is 15.5. So the second term is 15.5. Next one 15. Next one 14.5. You can guess next one 14 because you can see the pattern. But every time you're going up by 1 in the sequence, the actual terms themselves are going down by 0.5. They're going minus 0.5 every time. So that gives you a big clue that the rule for the nth term has something involving minus 0.5 times n. But if the rule was just minus 0.5 times n, then the first term would be minus 0.5 times 1 is minus 0.5, minus 0.5 times 2 is minus 1, minus 0.5 times 3 is minus 1.5, and so on. So you'd get a pattern that does go down by 0.5 every time, but it's the wrong pattern. So what you need to do is figure out what you need to add to all of these numbers to get all of these numbers. So minus 0.5, if I add 16.5 to it, I get 16. So the rule is every time I've got to go minus 0.5 times n, add 16.5, and then that will give me the right numbers that I want. 16, 15.5, 15, 14.5, and so on. So the rule in this case is that the nth term is minus 0.5n plus 16.5. So again, it's just the same as the first example in terms of the structure of how you do it, but the numbers are just a bit trickier with minuses and decimals involved.